The following video is about writing equations in parametric form and transformations of parametrics. So the first question, if I graph x and y, given that t is between -1 and 2, I would end up with this parameterization in this graph here. So that's something that we're pretty well aware of. Hopefully by now anyway. But if we wanted to figure out how to rewrite these parameterizations in some slightly different ways, given what it says, we have some options. So if you wanted to graph the same path and the same orientation, so starting here and moving to there, but you wanted your parameterization to be 2 times slower, which means you take twice as many values of t in order to do it. How could you do that? And what you would do is you would just take the t values that are here and divide them by 2. So if you take t divided by 2, notice that when you do t halves squared, that ends up being t squared over 4. And so that eliminates this 4 that's here. So this ends up being 7 minus t squared. And then my y coordinate, or my y parameter, which essentially ends up being my y coordinate at any value of t, is just t halves. So I divide both of these and replace t with t halves, essentially. And then in order to get to the same points, I need to take twice as many values of t to get there. So instead of going from -1 to 2, it's going to end up going from -2 to 4. And you can confirm this by plugging in -2 and plugging in 4 and see if you start and stop where you're supposed to. Now, if you want to graph the same path with the same orientation and t having a range of 3, just like we did here, but we wanted to start at t equals 0. So essentially instead of 0, or instead of -1 to 2, I want 0 to 3. Well, what I could do in order to do that is just, if I'm shifting all of my t's to the right one, I know how to make that kind of shift. I can just replace these things with t minus 1. So I take my original graph, my original parameterization, and I replace the t's with t minus 1. So then what happens is when I sub in 0, I get -1, just like I would have when I subbed in -1 up here. When I sub in 3, I end up getting 2, which is what I would have done originally. So that's just shifting my t values. Now, if I wanted to graph the same path with opposite orientation, so essentially starting here and working my way down, if I look at these parameters, my x values are really not going to be affected in any way by changing a sign on my t or anything, because, or at least on the inside of my t, because if I do -t, the quantity squared, that wouldn't change anything. But if I change my y values to have a -t minus 3, then what ends up happening is now all of my y values basically get flipped. And so notice I also had to change my t parameters as well, because if I plug in -2, I end up with -1 as my y value, which starts over here. And then if I substitute in +1, I end up with -4 as my y value, which is down here, which is what I needed it to be. Notice that plugging in -2 to 1 and plugging in 1 to 2, it's not going to change my x values at all, because those would get squared anyway. And so when I substitute in -2, the y value is now what I need it to be, and the x value is now the same as it would be if it was +2. Now, if I wanted to graph the entire path the same way with the same orientation as the original, but wanted the parameterization to increase in speed the entire time, what could I choose as a parameterization? And the temptation is to go something like x equals 7 minus 4t squared squared, and y equals t squared minus 3. So just replace the t's with t squareds. But the issue then is if I'm doing that, then my t would be from -1 to square root of 3. And the issue with that is from -1 to 0, then it would actually be slowing down. And then from 0 to whatever it is, or I'm sorry, not root 3, but root 2. And then from 0 to root 2, it would actually be speeding up. And I want it to speed up the entire time. So because I need it to speed up the entire time, that means that I need to actually have a shift with what's happening. So I need to do t squared minus 1 instead of t minus 1. So this should actually be a t squared minus 4. My fault on that. So I end up with 7 minus 4 parentheses t squared minus 1 squared. So I essentially replaced t with t squared. And then when I made this replacement, then what happens is everything speeds up as I move on. But I can't replace t with just t squared. I have to replace it with t squared minus 1 because I have to shift it down so that as t moves more positively, it's actually increasing the entire time. Whereas if it started at -1, it would actually be slowing down until I got to 0. Just the properties of squares, that's how it works. So now situation 2, let x equal 3t plus 1 and y equals 9 minus 2t squared. So we're going to graph this and notice the orientation here. But the difference between problem 1 and problem 2 is in problem 1, we were just trying to reparameterize things. Problem 2, we're going to try and change what the graph looks like. So now I want to write a set of parametric equations that translates this graph 2 units left and 1 down. So that would mean my vertex is now here. This point is now here. This point is now here. And so it's going to be like a graph that's shifted down a little bit. Just like when we did shifts in Algebra 2 and pre-calc at the beginning of the year. And what we notice is I just move my x left 2 and my y down 1. So I took these particular things, I subtracted 2, and I subtracted 1. And all that does is it changes where my graph goes by 2 to the left and down 1. I don't have to change my t values at all. Write a set of parametric equations that reflects the graph over the y-axis. Well, in order to do that, I need all of my y values to be the exact opposite of what they currently are. So I would multiply the y by -1. So it'd be -9 plus 2t squared. Also notice my t values don't have to change. So what that's going to do is it's going to take all of my y values and they're just going to flip like this. And it's going to end up going to here and going to here. So it'll look something like that. Orientation would be the same, but the graph just flips over the y-axis. So what do we notice if we're changing the graph versus changing the parameterization? Now in problem 1, nothing changed about what the graph looked like. It's just sometimes it started in a different spot, it went faster or slower, or went in a different method. And all we did was change what the t's looked like. But notice that the 7 and the 3 stayed the same. And if something changed, like in this one where it became t minus 4, that's just because when I replaced t with t minus 1, I can do some simplifying. But in problem 2, when I did this stuff, I actually had to change values that weren't part of t. So I had to multiply the entire equation by -1 or add or subtract things to the entire equation. So that's how you can do shifts and stretches on parametric equations. Now let's do these relatively quickly. If I have x and y equal to this, I see a cosine and a sine. So my thoughts are circle or ellipse, right? Then if I just substitute some things in, if I see cosine t plus 2 and sine t plus 2, that just means that instead of cosine sine, what I have is cosine plus 2, sine plus 2. So my center of my circle is going to be at 2, 2, starts here and goes in this direction as I just plot some points on cosine and sine. So notice that this D and E actually shift where the graph is. For A and B being negative or 5 and negative 5, if I have 5 cosine t minus 3 and negative 5 sine t plus 1, my graph ends up here. And then I kind of have to figure out, well, where is this thing starting? If I plug in 0 for t, I'll end up over here. And then I'm going to actually end up going clockwise this time. And the reason why it goes clockwise is because this b value is negative. So that means my sine starts by going down. And if my sine starts by going down, my y value here starts by going down. Then if my a and b are different, that means that it's going to be an ellipse. We kind of already knew that from a previous thing, but now just seeing it maybe can confirm it for us. And so I have an ellipse where my x radius is going to be 2 and my y radius is going to be 4. So I start up here, my x radius is 2 and my y radius is 4. And it starts at 1 or 3, 3 and goes counterclockwise because nothing is negative and I have cosine with the x and sine with the y. So it's counterclockwise in that regard. Then likewise for this last one, it's going to go clockwise because I have a negative cosine. And so my x values are going to start by moving negative instead of positive. And so when I start at -1, -4, it'll then just move clockwise in order to go around. Now, if I want to write a set of parametric equations, noticing that this is clockwise, I could have done what I did earlier, which was have a negative sine or cosine, like I did here. But I can also make the x sine and the y cosine. So that's another way that I can do that, because I'm actually going to, like, my maximized thing when I plug in t equals 0 would be at cosine, not sine. So it's actually going to be up first. And then cosine starts by moving down. So my y values are going to move down and my x values are going to move up. So it's going to go around the circle this way. So I can write a set of parametric equations like that to also go clockwise, sine with the x and cosine with the y. Now I can write two different sets of parametric equations for clockwise, just like I talked about. I can either have a negative for either cosine or sine, and to do that, or I can make them both positive, and then the sine is with the x and the cosine's with the y. Another thing that I want to talk about in this regard is if I want to go clockwise, I can actually do the exact same thing I have over here, but change the angle to be 2t. So if the angle is 2t, then everything stays the same. It just goes faster. So remember, we talked about faster and slower on the first page of this. So if I put 2t in for the angle instead of t, I can just realize that I'm going twice as fast. If I replaced it with 2 sine 1/2 t plus 3 and 2 cosine 1/2 t minus 1, I would have to go from 0 to 4 pi in order to complete the entire circle. So that's just what we were talking about up front. If I wanted to slow it down or speed it up, I can replace t with t halves or 2t or something like that. And then finally, I can write a set of parametric equations for this graph by just realizing that I have the vertex at 3, -4. So notice that I have x equals t plus 3 and y equals 2t squared minus 4. So this center or vertex is what we talked about earlier, noticing this 1, 9 was my vertex. I see that shifting occurring here. And then when I wanted to shift it, I just shifted -2 and -1 for X and Y. Similarly, on number 6, I can look at a picture and see how that works as well. So I have the vertex at 3, -4. Then I notice that my A value of my parametric, or my A value of my parabola is 2. And so because that's the case, then I can have a 2 in front of this. And if I wanted to, I could rewrite this by substituting the t plus 3 in where x is. So subtract the 3 over, I get x minus 3. And I end up with the equation of the parabola in rectangular form as well. So I could do that as well in vertex form if I wanted. But just kind of seeing how it works in parametric form is a valuable experience, seeing that this +3 -4 does a shift of the graph, and this 2 does a stretch, just like we did when we were doing shifts and transformations for the last 2 years.